Now see here, if a body is projected with speed v greater than the speed Ve, that is escape speed, from the surface of earth, find its speed in interstellar space. Now see here, when you are projecting any body from the surface of earth, so when the body is on the surface of earth, it has potential energy as well as kinetic energy. When it is going into the interstellar space, it has only kinetic energy, no potential energy, because we ignore the presence of any other heavenly body. So now see, apply the here concept of this energy. When the body is on the surface of earth, it is kinetic energy is this when it is projected with the speed v, and potential energy is minus gmm upon r. When it is in the space, interstellar space, suppose velocity is mv dash square, potential energy is 0. So now we can write here this m and this m will get cancelled. By taking the LCM, we will be getting v square minus twice of gm upon r is equal to v dash square. This is equal to escape speed. So minus ve square is equal to v dash square. So v dash is equal to under root of v square minus ve square. So speed of the body in the interstellar space will be this much. Now see at this example, a satellite orbits around Earth at a height of 400 km above the surface. How much energy must be expended to rocket the satellite out of gravitational influence of Earth? Mass of satellite is given to you 200 kg, mass of Earth is this much, radius of Earth is this much. So we can write here the radius r is equal to this. So see here, when the satellite is in the orbit at height h, then its total energy is this much, minus gmm upon r plus h plus half mv square. V is the orbital speed, that is gm upon rh. So by putting this, you have got this. This is the formula for the total energy of the satellite. And you know, energy required to send the satellite out of the gravitational influence is known as binding energy. That is also minus gmm upon 2r, that already we have derived. So binding energy is here the positive of the total energy of the satellite. So that I have written this much, gmm upon twice of r plus h. Put the value of g, put the value of mass of earth and mass of satellite, and this one radius of earth and height of the satellite from the surface. Then if you calculate all this, you will be getting this. So this question is based on the binding energy of the satellite. Now see here, the distance of two planets from the sun are 10 raised to power 13 and 10 raised to power 12 meter respectively. Find the ratio of time periods and speed of two planets. You are given R1 is equal to 10 raised to power 13 meter and R2 is equal to 10 raised to power 12 meter. For this time period is T1 and for this time period is T2, and velocity is V1 and velocity is V2. So actually this question is based on the Kepler's law, that is the law of period. We know T is proportional to RQ, we know this. So we can write T1 upon T square, this is T1 square upon T2 square is equal to R1 cube upon R2 cube. So we can write T1 upon T2 is equal to R1 upon R2 raised to power 3 by 2. We can put the value of R1 and R2, that is 10 raised to power 13 upon 10 raised to power 12, 3 by 2, that will be here 10 root 10 if you solve it. So there is only 10 and take this one, this is coming here. So the ratio of time period is 10 root 10. Now we can get the ratio of velocities also. So see here, for the velocities we can use the formula, this one, v is equal to 2 pi r upon t. So we can write v1 is equal to 2 pi r1 upon t1 and v2 is equal to 2 pi r2 upon t2. So v1 upon v2 can be written here r1 upon t1 multiplied here t2 upon r2. So we can write here r1 upon r2 into t2 upon t1. We know the value of these. R1 upon R2 is, that is the 10 raised to power 13 divided by 10 raised to power 12. So, we can write here 10 raised to power 13 divided by 10 raised to power 12 into, here it was here 10 root T1 upon T2 was there 10 root 10. So, that will be here 1 upon 10 root 10. So, now you can cancel here. So, you will be getting only after solving this, because 10 raised to power 12 and 13 will get cancelled, only 110 will be left behind here, that will be cancelled to this. So, you will be getting equal to 1 upon root 10. So, ratio of the speed of these two planets is 1 upon root 10. Now, see in this question, at what height above Earth's surface value of G is same as in a mine 100 kilometer deep. Suppose the value above the surface is given by G dash is equal to G into 1 minus 2h upon R. Already we have derived this formula. And the below the surface of Earth is given by, that is here GD is equal to G into 1 minus D upon R. It is saying at what height above the Earth's surface value of G is same. It means these to be same. So, you can write G into 1 minus 2h upon R is equal to G into 1 minus D upon R. This and this cancel, and this also this will get cancelled. You will be getting 2h upon R is equal to D upon R, R cancel. So, h is equal to D by 2. So, already is given 100 kilometer. So, h is equal to 100 by 2 is equal to, that is 50 kilometer. Now, see here this question is conceptual one, which is based on actually escape speed. There is no atmosphere on the moon. Explain this on the basis of escape speed. Now, see here, if you see the Earth, this is the center point, this is radius r and mass is m, and escape speed on the surface of the Earth is 11.2 kilometer per second. So, and the gases which constitute atmosphere has got their thermal speed is less than this. So, these gases cannot escape the gravitational field of Earth, that is why Earth has atmosphere. So, now see about moon. What happens in case of the moon? In case of the moon, this is the radius of the moon and mass of the moon. Both are as compared to Earth is very less. Because of that, here escape speed on the surface of the moon is around 2.5 kilometer per second, and gases has got thermal speed more than this. So, all the gases which constitutes atmosphere escapes from the gravitational field of the moon. As a result, moon has no atmosphere. Now, see here, taking moon's orbit around Earth to be r and mass of Earth 81 times the mass of the moon. Find the position of the point from the Earth where the net gravitational field is 0. Suppose this is Earth and here is moon, and this distance is r. Suppose at a distance x from the Earth here, net gravitational intensity is 0. So, obviously, the gravitational intensity due to Earth and gravitational intensity due to moon both will be equal and opposite. So, that is why it will become 0. So, we can write here the gravitational intensity due to Earth, that is GME upon x square, is equal to GMM, that is the gravitational intensity due to mass of the moon upon r minus x square. This is the distance r minus x. Now, we know it, mass of the Earth is 81 times the mass of the moon. So, G will get cancelled. So, 81 times of the mass of the moon, x square is equal to mm upon r minus x whole square. This can cancel. Now, we can calculate here, this side here, x square upon r minus x whole square is equal to 81. So, we can write x upon r minus x is equal to 9. So, x is equal to 9 r minus 9 x. So, 10 x is equal to 9 r. So, x is equal to 0.9 r. So, this distance be here 0.9 r from the earth, where net gravitational field will be 0.